Today you're going to take benchmark 3. But before you take the benchmark, we're going to review the benchmark study guide in live worksheets. After the review, you're going to take the benchmark in performance matters. So good luck. Pay attention on the review. And if you did the study guide and you pay attention, I know you're going to do a great job on the test. We'll see you next time. Okay, welcome back. We're going to be going over the study guide for the benchmark. This is page 1. Speed is defined as the speed is distance divided by time. So like when you think of speed on the interstate and you see the signs posted on the side of a road, it says miles per hour. Per means divided by. So that's miles is distance per unit of time, and that would be like the hour. So it would say like miles per hour. Speed that includes direction is velocity. Okay, now remember with speed, you can speed up and have positive increase. You can slow down and you can be changing direction. So acceleration is a change in velocity, so it can be positive and be speeding up. It could be slowing down. Or remember, velocity includes direction, so it could be changing direction. Okay, it says an airplane or a plane flies 3,000 kilometers from Hawaii to Los Angeles in 6 hours. What is the velocity of the plane include direction? Well, velocity is speed and direction. So the speed of the plane would be the distance, 6,000 kilometers, divided by the time, 6 hours. Well, 3,000 divided by 6 is 500. And the direction it would be flying would be east. It would be going from Hawaii out in the middle of the ocean towards California, which would be towards us. So it would be going from west to east. So it would be going 300 kilometers per hour east. Look at the graph at the right. What is plotted on the y-axis? On the y-axis is grams of solute, and on the x-axis is temperature. Which one is the independent variable? The independent variable is always on the x-axis. So temperature, and since it is plotted on the x-axis. Okay. We made 7 trips to the grocery store over the weekend. Because this little chart, activity, and uses of gasoline. Here we see driving to the grocery store, use 10 liters of gasoline. We did that 7 times, so we've used 7 times 10 or 70 liters of gasoline. The international or SI units is based on multiples of 10, just like we count. What is the abbreviation for millimeter? It would be mm. Which is 1/1000th a meter. cm is the abbreviation for centimeter, which is 1/100th. Okay. Milli, like a millennium, is 1,000 years. Centi, like a century, is 100 years. M is the abbreviation for meter, and there are 1,000 meters in a kilometer. Chemical reaction that releases energy. Release means the energy comes out. Okay. Coming out is exiting, so it would be exothermic. What would be the most appropriate metric unit to measure the length of a swimming pool? Well, we wouldn't measure it in millimeters or centimeters. The length of the swimming pool or our house, we would probably be measuring in meters. And then kilometers would be too big. Okay? To measure a fly's leg is very small, so we would be using millimeters in the thousandths of a meter. Joe rode his bike 80 meters in 20 seconds. What was his average speed? Well, the triangle is distance divided by time equals speed. So his distance is 80 divided by the time of 20 seconds. 80 divided by 20 is 4. Because the zeros cancel, and it's 8 divided by 2. And the unit is meters per second. Acceleration is the rate at which velocity changes. You travel 800 miles to get to your destination. So 800 is the distance, and the speed is 40 miles per hour. So we're going to divide, and so 800 divided by 40 is 20. And it says, to get to your destination, average speed, how long will it take? It is going to be hours. Okay, we went 40 miles per hour. So the unit for time would be hours. Weight is a measure of the force of gravity. Remember, weight is measuring how much gravity is pulling us to the earth. The amount of matter in a substance is mass. And force is a push or a pull. Okay, that's page 1. Okay, so this is page 2. Newton's first law of motion states that an object at rest will stay at rest, and or an object in motion will stay in motion unless acted upon by an unbalanced force. Okay, so things don't move on their own. They just don't start moving by themselves. And if they are moving, they will keep moving indefinitely unless there's an unbalanced force that causes them to change their motion. This is known as the law of inertia, which is the tendency of an object to stay or continue to doing what it's already doing. Newton's second law of motion states that force is equal to mass times acceleration. Equal and opposite forces acting on the same object are called, well, if they're equal and opposite, they're going to cancel out. They're going to be balanced and cause no change in motion. An object's motion. The type of friction on a falling object experiences through the air is called fluid friction. Remember, fluid friction is sliding friction when it's sliding to a liquid or a gas, which is air is a gas. Which of Newton's law says for every action there's an equal and opposite reaction? That would be the third law. If a gun shoots a bullet and the kickback, the backwards force is 10 newtons, what force will be exerted on the bullet? Well, Newton's law right here says for every action is equal and opposite, so it would be equal, it would be 10 newtons. A compound is made of 2 or more elements, not physically combined. It might be tightly combined, but that is not the answer we're looking for. It would be chemically and certainly not magically. A mixture is 2 or more substances that are physically combined, and they can be separated by physical means. Okay, select which one is a mixture, element, or compound. Well, air, we know there's oxygen in the room because you're breathing it to stay in line. You're exhaling carbon dioxide, so you know that's mixed in the room, and the atmosphere is mostly nitrogen. So air has to be a mixture. NaCl table salt has a formula, so that's how we know it has to be a compound. Carbon has an element symbol, so it's an element, and then pure hydrogen peroxide, H2O2, also has a formula, so it's a compound. The kinetic or particle theory of matter says that all matter is composed of tiny particles, constant motion. Fill out the chart for the phrases of matter. Solid, definite shape, yes. Definite volume, yes. Liquids do not have a definite shape, but they do have a definite volume. Gases have neither a definite shape nor a definite volume. Okay, so now we can answer this question. Which phase or phases of matter have no definite volume? Well, both the solid and the liquid have a definite volume, only the gas. Which phases of matter have a definite volume but take the shape of its container? Well, a liquid does not have a definite shape, so it will take the shape of its container, and it does have a definite volume. Okay. Families on the periodic table are in the columns going up and down, and the periods or energy levels go across in the rows. All the elements in a group, which is a family or a group, have the same number of valence, those outside electrons. Elements on the left side of the periodic table, so over here. So things like chrome, manganese, iron, gold, silver, those are all metals. And elements on the right side of the periodic table, like the oxygen we're breathing, nitrogen, carbon, and then the things like in neon and lamps, okay, all non-metals. Okay, and now we'll be going on to page 3. All right, this is page 3 of the workbook. When a metal bonds with a non-metal, it forms an ionic bond. Those are things on the left bonding with things on the right, things like salt. Two non-metals bond together, like an oxygen and oxygen, make a covalent bond. In a chemical reaction, the reactants are the things at the beginning. So let's look over here. In this equation, MgCO3, the things we start off with on the left side of the arrow are the reactants. Reactants are found on the left side of the arrow, and the products are found to the right. In this equation, MgCO3 is the reactant, and the MgO and the CO2 are the products. You set up an experiment to test the hypothesis that plants will grow faster in red light. So it shows over here we got one in red, green, and yellow. The constants in this experiment are the type of plant, the amount of water, and the fertilizer. Look at the picture. What else should be constant? Well, if you look at this picture, the type of plant is different. So the type of plant should be the same. In the experiment, what is it that you're changing and testing? You're changing the color of light. You test a bunch of different softball bats to see which one will make your softball go the farthest. The thing that you're in control of, the thing that you're changing, the thing that you're testing is the independent variable, which are the different bats. The thing you think may depend on the type of bat is the distance the ball goes, so that's the dependent variable. Select each statement that's true or false about the nonmetals. Okay. Nonmetals are not all found pure in nature. Oxygen is a nonmetal. It's not found pure in nature. A lot of them, all the halogens are highly reactive, so they'll all react. So they're not found pure in nature. We just said that oxygen is a nonmetal, and it is not a liquid at room temperature. The noble gases are nonmetals, and they don't react at all, so they're not all very reactive. They're all found to the right of the zigzag. That's true. They're all on the right side of the periodic table. The prefix co means to share, like cooperate, commingle. Okay. Or like if animals cohabitate, they share the habitat. The type of bond formed when electrons are shared is covalent. Physical or chemical. Adding heat makes a solid melt. Phase change is physical. Rusting produces a new substance that was chemical. Burning a log is a chemical change. It produces a new substance, the ash. Chopping wood changes the shape of the log, but it does not produce a new substance, so it's physical. Putting a paper in clip an acid, okay, it reacts with the acid, so that would be a chemical change. Bending the paperclip changes its shape and only its physical properties, so that's physical. Breaking glass is a physical change. It doesn't make a new substance. You just have broken pieces of glass, but they're all still glass. The table at the right shows the student's height increases, their weight also increases. Okay, now let's take a look at page 4. Okay, so this is page 4. This is the last page of the study guide. If you tested an unknown liquid in a beaker, and you had a hot plate, temperature probe, you would probably be able to determine which property. Well, density is mass divided by volume. Okay? And there's no way to find the mass or the volume, so we can't do that. We could find the boiling point. We have a hot plate and a thermometer. There's no way to measure the nitrogen level, and there's no way to tell the chemical composition of the hot plate and a temperature. So we would be looking at the boiling point. The amount of gravitational force between two objects depends on the mass, like the mass of the Earth or the mass of the Moon or the mass of the Sun, and the distance from each other, which would have the least gravitational force. Well, the ones that would have the least mass. It would be the farthest apart. So these are both 1 meter apart. So out of these two, the 10 kilogram balls would have the least gravitational force. But over here, the 10 kilogram balls are even farther apart. So they're the least mass and the farthest apart. So they would have the strongest gravitational force. A ramp is an example of an inclined plane. Chopping wood with an axe is an example of a wedge. If you move a 30 Newton box a distance of 15 meters, how much work will you do? Well, it tells us the force is 30 newtons, and the distance we moved it is 15. When the numbers are on the bottom together, we multiply. So 30 times 15 is 450. And the unit for work, meters is distance, kilograms is mass, newtons is force, joules is work. The number of times a machine multiplies the effort force is called the mechanical advantage. You use a more powerful motor to run a machine. The same amount of work is going to get done. Remember, machines don't change the amount of work to get done. The same amount of work will get done in less time. Okay, your mass on Earth is 60 kilograms. What would your mass be on the moon? Well, it wouldn't change. Remember, mass is the amount of matter in an object, and the amount of matter in an object wouldn't change because you take it to the moon. If you throw a baseball upward, it'll travel upward until gravity forces it back to Earth. This is known as Newton's. Well, an object in motion would stay in motion unless the unbalanced force of gravity acts upon it. So that's Newton's first law. For work to be done, an object must move. And we said there's no motion, there's no work. A distance is a result of a force, which is the equation for work, which is force times distance. Was work done on the punching bag? Well, the force made the object move. So yes, the amount of work done in a certain period of time is power. Fill out the triangle for power with the letters for each variable. So it's work divided by time goes on the bottom equals power. 4,000 joules of work are done in 20 seconds. 4,000 would go on the top, 20 seconds would go on the bottom. So how much power was used? It would be 200 watts. It's the unit for power. Okay. If a machine uses a combination of two or more simple machines, it is called a compound machine. Okay, just like a chemical compound is two or more elements bonded together. Look at the box from the periodic table. What is the element name? Well, it's right here, sodium. What is the element symbol? It's right there in the middle, Na. What is the average atomic mass? That's right down at the bottom, 22.99. What is the atomic number? That's that number at the top. It's 11. And that's page 4. If you've done the study guide and you looked over everything you missed and made corrections, I'm sure you're going to do a great job on the test. So good luck, and we'll see you next time.